Welcome to Mthpt-137, Math for Technology. We are starting off our video series in our Unit 1, and in this unit we are solving quadratic equations. There are multiple methods for doing that. We are going to start by using the factoring method. Hopefully you've had a chance to look over the note sheet that is in front of you. I'm not going to be reading it verbatim. I'm going to be going through the examples with you. Then you can also let me know if you have any further questions. One of the big things about quadratic equations, though, that I do need to make sure you note is that the highest exponent in a quadratic equation is the squared term. So this is very important that as we're working through these, all of them have a squared term. They may be missing this linear term, the bx. They might be missing the constant, but they should not be missing the x squared. Linear terms have a single solution. Quadratic equations have two solutions. So we want to make sure we always have two solutions in our problems. I'm actually going to go ahead and jump on down to example 2 and work through that with you. What I want us to realize is that first thing, we have two products. So I have this quantity times the second quantity, and I have to get 0 out of it. So I want you to think about when you're multiplying to 0, how can you do that? The only way to multiply to 0 is if one of the terms is 0. You could do 5 times 0, you get 0. You can do 0 times -6, you get 0. You can do 0 times anything and you will get 0, but only one of them needs to be a 0, not both of them. So what's happening in this example 2, when we have the quantity of x minus 2 times the quantity of x plus 3 equals 0, the first quantity has to equal 0, so x minus 2 must be 0, or the second quantity of x plus 3 has to be 0. It's not both, it's an or situation. Now these look like linear equations, which you hopefully have solved before. At this point, hopefully you recognize that we are going to add 2 to both sides to isolate the x, and we get an answer of x equals 2. In the other expression, we're going to minus 3, so we get an answer of x equals -3. So we have two answers. X could be 2 or x could be -3. Now we can check that in our process. If we come back to the original, 2 minus 2 times 2 plus 3, does that give me 0? 2 minus 2 is 0, 2 plus 3 is 5, 0 times 5 is 0. Yes, it does work. And again, -3 would also work. The other one would just be 0. Actually, let's go ahead and do it over here on the side. It would be -3 minus 2 times -3 plus 3. -3 minus 2 is -5. -3 plus 3 is 0, and that also equals 0, so it checks. So we will have two solutions, and that will work for every quadratic equation. So there are some steps here to make sure. We want to make sure it is equal to 0. We're going to factor it. Then we're going to set each one equal to 0 and solve them. And then check. Now I'm not going to check every problem. You can check them. In this example 3, it is already equal to 0. So now I'm going to practice my factoring. Factoring is a skill that is a prerequisite to this class. I may not factor the same way you do. I'm going to work through my method. If you have some questions on my method or on your method, just let me know. So what I have here is I know that whatever I do, to get x squared, I know it is x times x. I always bring down the first sign, then I don't have to worry about it. And then I ask myself, because I remember what it's like to multiply a binomial times a binomial, I get the positive 5 in this case by multiplying. So a positive times a what is a positive? Well, a positive times a positive is a positive. So I know I have to multiply to get to 5, so I'm going to ask myself, well, what multiplies to 5? Not too many options in this case, it's just 1 and 5. do those numbers, the question now is, do they add to 6? Because when we do the multiplication and we push these apart and multiply them out, they have to add to the middle term. Well, 1 and 5 do add to 6, so those are our options. I always put the first one in the largest one in the front and the smaller one in the back, and it always works then. So I can check. If I want to multiply this back out, I would get x squared plus 6x plus 5. Now that I've factored it, I want to separate them into smaller equations. I have x plus 5 equals 0. I have x plus 1 equals 0. So I am going to simplify those. Minus 5 from both sides. One of my answers is x equals negative 5. Then I'm going to do minus 1. Minus 1 from the other side. I get x equals negative 1 for the second answer. I will show the check on this one. So I have negative 1 squared plus 6 times negative 1 plus 5, and I want to know if that equals 0. Negative 1 squared is 1. Positive 6 times negative 1 is negative 6. 1 minus 6 is negative 5. Negative 5 plus 5 is 0, so that checks. Now I'll try the other one to make sure it checks. My other answer was negative 5. Negative 5 squared plus 6 times negative 5 plus 5, does it equal 0? Negative 5 squared is 25. 6 times negative 5 is minus 30. Does 25 minus 30, which is negative 5, negative 5 plus 5, does that equal 0? Absolutely. So both answers check. Moving on to example 4. We have to make sure it is equal to 0. This one is not, so our first step is to move the 36. So I'm going to minus 36 on both sides. I end up with x squared plus 5x minus 36 equals 0. I'm going to go straight into factoring, writing in my parentheses, separating my x's. I'm going to bring down the first sign, it's a positive. And I'm going to ask myself, a positive times a what equals a negative? Well, the only way to get an opposite is to do a negative. Now I need to multiply to 36 and subtract to 5. So I'm going to list out what multiplies to 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. The pair that subtracts to 5 is 4 and 9. I'm going to put the larger number in the front and the smaller number in the back. Now I'm going to go ahead and move on to the next step where I separate them. So I have x plus 9 equals 0, and I have x minus 4 equals 0, minus 9 from both sides. One of my answers is negative 9. I'm going to add 4 to both sides. My second answer is positive 4. On this one I am not going to check. Okay, we have 3 more examples to work through. They are a little bit different than the ones we've done before, so they each have their own certain qualities, so you want to check for those things. In this first example 5, we have a 2-term problem, and what you might notice is they have something in common. Both the 3 and the 9 are divisible by 3, and they both have at least one x. So this is a greatest common factor. It's something they have in common, and it's the largest thing they have in common. When that occurs, you want to remove it first from the expression. 3 divided by 3 is 1. I had x squared, but I took one of those out, so it left me with 1. 9 divided by 3 is 3. I had an x, but I took it out, so I have no x's left. Now when you look at your parenthesis, you want to ask yourself, is your parenthesis to an x or to an x squared? and my parenthesis is just an x, not an x squared, which means I'm done factoring it. I'm going to go ahead and set each part. This is one of the factors, it just isn't adding or subtracting anything. So I have 3x equals 0 as one term, or one expression, and I have x plus 3 equals 0 will help me find the other answer. On the 3x equals 0, I'm going to divide by 3 because those are multiplying. So I get an answer of 0. Over here I'm going to minus the 3. So I get an answer of negative 3. And again, you can check it. I'm not going to. Number 6, I'm actually going to show you another method for solving these. Whenever you have simply the x squared term, no linear term, and a constant, the fastest way is to just undo the square. To undo a square, use square root. So I'm going to square root the x squared, and I'm going to square root the 4. When you square root x squared, you get x. The one that most people think of when you square root 4 is 2. So yes, 2 times 2 is negative 4. But it does have another answer because remember, all quadratics have 2 answers. You need to remember that the negative of that number also will give you what you're looking for. So negative 2 times negative 2 is also a positive 4. So make your life a little bit easier when you just have the x squared and then you just have a constant. Just go ahead and square root both sides. This last one has an extra step because what you'll notice is there's a number in front of the x squared that cannot be factored out. Before we can even worry about that, we need to make sure it is equal to 0. Because it is easiest to factor with the a, which is the x squared term being positive, I'm going to minus the 7x and the 20. That way I keep my x squared positive. I end up with 6x squared minus 7x minus 20 equals 0. Now I tend to use a method called bottoms up to factor these. I just find it easier because it's working with information I already know. To do that, I'm going to remove this 6. I'm going to turn this problem into one that I'm already comfortable with. To remove the 6, I pull it over here and I multiply it by the 20. I end up with x squared minus 7x minus 120. This now looks like the previous problems that we factored. So I'm going to split the x's, bring down the negative sign, ask myself a negative times a what is a negative? That's a positive. So here I have 120. I'm going to ask myself what is multiplying to 120 but subtracting to 7? I tend to write down all the options. You can skip around if you like. The only issue, what happens sometimes is you'll miss one by skipping around. But I do understand this can get tedious, especially with large numbers. 5 and 24, 6 and 20, 8 and 15, 9 doesn't work, 10 and 12. So I'm going to glance down through those pairs and I'm looking for the one that subtracts to 7. Well, 8 and 15 subtract to 7. I'm going to put the larger one in the front. So 15 is larger than 8. 8 then would go in the back. Now before I would be done and I would go straight to finding the answer. But remember I moved the 6 to make this process easier. So I have to put it back or do the opposite of what I did. Since I multiplied to make my life easier, I now have to divide so I don't forget that I used it. So I'm going to divide both of my numbers by 6 to undo this multiplication. You can leave your answers in fractions or decimals, it's your prerogative. 15 over 6 doesn't go to a whole number, but they're both divisible by 3, so I end up with 5 halves. 8, 6 again does not go to a whole number, but they're both divisible by 2, so that would be 4 thirds. Now I can go to just solving them. So I have x minus 5 halves equals 0, x plus 4 thirds equals 0, Go ahead and add the 5/2. I end up with x equals 5/2. You can do 2.5, 2 1/2, that's your choice. I'm going to minus the 4/3 from both sides. I get x equals negative 4/3. And those are my two answers, which again I can go back and check with my 6x squared plus 7x equals 7x plus 20, and they would check. So on your assignment, remember you're doing all of 1 through 20. I know you don't have any answers. If you get stuck anywhere along the line, please do not hesitate to let me know, and I will get you unstuck. And a quick picture of where you're stuck would be very helpful. Thank you and have a good day.